Hello students and welcome to this exercise 6G video which focuses on the area of a triangle using three different rules. Now the first of these three rules is the basic formula for the area of a triangle which you would have used before in Year 11 Maths General and all your previous years of schooling and high school essentially. This is the rule that says the area of a triangle is equal to 0.5 times the base times the height. Another way of saying it is the area equals base times height over 2. Now, the reason this rule works is because a triangle's area makes up half of a rectangle with the same base and height. Now, when we say base, we're talking about the length along the bottom of the triangle, and when we say height, we're referring to the perpendicular height of the triangle. So that is the height that makes a 90-degree angle with the base all the way up to the tallest point of the triangle. Now, I want to remind you that we still have this rule in our repertoire. So even when you see questions in these trigonometry chapters that ask for the area of a triangle, if this rule is possible, so if you know the base and the height, you don't have to use trigonometry or Heron's rule, which is another rule we'll see today. You can still use this rule here. Now, before we get into these new rules, though, we just need to review the way we label non-right angled triangles. And the way we go about doing this is by marking the interior angles with capital letters. So when I talk about the interior angles, I mean at each of the vertexes or the points on the outside of the triangle, we mark those angles with capital letters. So this is angle A up here, this is angle B down here, and this is angle C in the bottom left. We could use any letters we want, but the convention is to use A, B, and C. Now, side lengths are marked with lowercase letters. So we're using the same set of letters, but we use the lowercase versions instead. And the rule is, if I have angle A here, the side opposite to that, so down here, is lowercase a, and that's how we label them. So angle B is in the bottom right, so the angle across from that, the angle opposite that is the side opposite that is side lowercase b. Angle capital C is in the bottom left, and the side which is opposite to that is labeled lowercase c. So that's the convention for labeling these triangles. And all of the rules that we'll look at today use these letters in them. So we'll need to make sure that we understand letters are referring, which letters are capital letters, those are the angles, which letters are lowercase letters, those refer to the sides, and we also need to know the relation between capital A and lowercase a. So the first of these rules is using sine to calculate triangle area. And I will show you why this rule works when you return back to school. But for now, what I want you to focus on is just the mechanics of it. So how do we actually use it? So we'll talk about the reasons behind it later on, why it looks this way. But the way this rule works is there's three different versions of it, and each one focuses on a different angle within the triangle. So if I know angle A, I have to use this top version. If I know angle B, I have to use this middle version. And if I know angle C, I have to use the lower version here, the third one. So what the rule says is, I'll look at the first one first. It says the area of a triangle is equal to 1 over 2 multiplied by lowercase b multiplied by lowercase c multiplied by the sine of capital A. So what I should be noticing here is B and C, they're side lengths. B refers to this side down here, and C refers to this side over here. Now, capital A is actually the angle in between those two sides. So that's the way this rule works. It uses three different letters, one of them being a capital. The capital refers to the angle. And the lowercase letters are the two sides which are next to that angle. So angle A comes in between side C and side B. So therefore I can use this rule here if I knew what capital A, B, and C are. Now instead, if I knew what angle C was, for example, I would have to use angle C and then the two sides next to it. So I'd have to use angle C, side B, and then side A, which is this side here. I hope that's clear, and now we'll take a look at an example to make sure it really sinks in for us. So find the area of this triangle correct to 1 decimal place. Now I can't use base times height over 2 because I don't know this base length, and I also don't know the height of the triangle perpendicular to that base. So because I don't know those two pieces of information, I'm going to have to use a different rule for the area of a triangle. And what I do have is I've got angle A, which is 135 degrees, and I've got the two sides which are next to it. So I've got two sides and an included angle. That means I can use the sine rule that we just looked at for finding the area. So the area is equal to 1 over 2 times BC times the sine of capital A. And if I knew a different angle, the rule would look slightly different, but it would still use all three letters, and the capital would just be the angle I've got instead. Now, area equals half BC, so 1 over 2. Side B here is the side that's opposite angle B. So the side opposite angle B is 5. So half times 5. Now C is across from angle C. So side C is 6. And then it's the sine of angle A, which is 135 degrees. Now, our calculators can actually handle all of this in one step because it's just multiplication. So I can go 0.5 for a half times 5 times 6 times the sine of 135. And the answer here is 10.6 because it's only to one decimal place. And because it's an area and my original was in centimeters, this will be in centimeters squared. So that's using the area rule, which includes sine in it, to work out the area of a triangle. Now, this next rule is called Heron's rule for triangle area. And the way that this rule works is it takes in all three side lengths as arguments. So that means if I know all three side lengths of my triangle, I can use this rule here. And what the rule says is, first of all, I calculate S. And S is 1 over 2 multiplied by the sum of those three sides, A plus B plus C. So we can call that the semi-perimeter or the half perimeter because it's all three sides added together, which is the perimeter, and then divided by 2, so the half perimeter. But once we've done that, we actually use this rule here. So this is really Heron's rule, and S is just something we need for Heron's rule. So the rule says it's the root of S multiplied by S take A, the side length, multiplied by S take B, the side length, multiplied by S take C, the side length. So this rule takes a few steps, but we'll just see how it goes. We'll do an example right now. It says the boundary fences of a farm are shown in this diagram. Find the area of the farm to the nearest square kilometre. So this is a triangle that I want to find the area of. I know its base, but I don't know its perpendicular height here. And I also don't know any of the interior angles. So I can't use any of the first two rules we looked at. I have to use Heron's rule. So for Heron's rule, I need S first, and S is half of A plus B plus C. Now, lowercase a, b, and c, they all refer to the side lengths. So what I'm really looking at is a half outside of 9 plus 11 plus 6. Okay, so 9 plus 11 is 20, plus 6 is 26. So I'm looking at... Sorry, guys. Let's just go back to where we were. There we are. So, sorry, what I'm looking at is half outside of 9 plus 11, which is 20, plus 6, which is 26, which is 13. Okay, so S is 13, but what I really want to do is use the area formula, which is Heron's rule. And that formula says the area is equal to the square root of S outside of S take A, outside of S take B, outside of S take C. Now, it doesn't actually matter which letters which letter I choose to be A. So 6 could be A, or 9 could be A, or 11 could be A. It doesn't really matter because they're all just we're doing the same thing to each of the letters. So let's substitute in now. So S was 13, so it's 13. Outside of 13, take 6. Outside of 13, take 11. Outside of 13, take 9. Okay, so we've got the square root of 13 outside of 7, because 13 take 6 is 7. 13 take 11 is 2. And 13 take 9 is 4. So it's the square root of 13 times 7 times 2 times 4. On our calculator real quick, 13 times 7 times 2 times 4 is 728. So we're looking at root 728 here. Now, I could leave it as root 728 because that's an exact answer. And I could say root 728 kilometers squared, because these are in kilometers. Or I can give a decimal answer here. Because, for example, if this was my farm and someone said you have 728 kilometers squared of land, I wouldn't really know how much land that refers to. I would need to do the calculation and see what decimal answer I get. So root 728 is 26.98 kilometers squared. So this answer here is actually more precise because I've cut off some decimals when I've written this one, but this one is probably a more sensible answer to give in a real life context, which is often what we're doing in general maths. So thank you guys. Those were the 3 rules for triangle area, which you can be asked to use in general maths. I'll give you some questions to work on as well, and we'll see how that goes. Thanks very much.